This is a titration problem example. So I'm going to walk you through how to do the titration problem, and then you're going to try some of your own. You have two substances that will be mentioned in the problem. The one that you start with is the one you know the most about. In other words, you'll know the volume and the molarity of that one, and you'll only know one thing about the other one. Another way to decide is whichever one is asked about in the question is the one you don't start with. So we want to start with KOH. Then once you decide that, what your goal is to take the two pieces of information that you know about it and get to moles. So as you know, there are two ways you can do that. You can take the molarity formula, or you can factor label it. You need to get your milliliters to liters either way. So that's what I'm doing here. And some of you do that in your head, and that's okay, just don't make a mistake. And I generally do it the factor label way, but I'll go ahead and show the molarity way here first. We take 25 divided by 1,000 would come out 0.025 liters. And then we're using the molarity formula. Molarity equals moles over liters. We would say 1.25 because that's the molarity of the KOH, and that's the one we're using, equals X over 0.025. And then I always just put the molarity over 1 and cross multiply it, but it doesn't matter as long as you solve for X correctly. So your algebra skills again, be careful with those. And I am getting 0.03125 moles. And that's your KOH. Then you do a mole to mole, so you have to take that and convert it to moles of the other substance. So you put that over 1, do a mole to mole, moles of KOH to moles of H2SO4. Now, to do that, you need a balanced chemical equation. So if a balanced chemical equation was not given to you, then you would have to write it. It's real easy. You just do a double replacement. So it doesn't matter whether you write the acid or the base first. And we already learned that it's going to produce water and a salt, but I'll just go ahead and do it as a double replacement so you can see what the salt is. So I'm going to take the sulfate off of the potassium, off of the hydrogen, and put it on the potassium. The 4 is a part of sulfate, so I bring that with me. And then I do not bring the 2 because that's not part of a polyatomic, and then put the OH with the H. Then, and this is the part that students will sometimes forget, and it makes balancing really hard, do your charges and balance them out first, because if you don't, like I said, it makes it very difficult to balance the equation. So that would put a 2 down here, and then these 2 cancel each other out. And then you balance your equation, and you're good to go. So then, up in the mole-to-mole conversion, you look for the numbers based on the substance. So H2SO4 has a 1 in front of it, and KOH has a 2 in front of it. So put a 2 there. So we take our moles divided by 2, and I think I'm going to switch to the next page so you can actually read what's going on. When I do that, So this is just what I did and what I was saying before. I'm just recapping it so we'll remember where we got the stuff. We get 0.0156 25, and that is our moles of H2SO4. So now we need the molarity formula again, this time for the H2SO4. We know the moles are 0.015625. Then we go back to the original problem, and it tells us the volume. So we had 50 milliliters. So take your 50 milliliters, change it to liters. So that'd be 0.050 liters. Okay, so that goes on the bottom. And it comes out that the molarity is 0.3125. And then I'm going to go back and check SIGDIG. I have 2 here, 3 here, 3 here. So I need 2. So I'm going to round that to 0.31. And your label has to come after your number. Like this is just a variable over here. This is a label over here because it comes after the number. And then that's the H2SO4, and that's our answer. That's how you do it using the molarity formula. Now I'm going to make another one that's going to show you, or I'll just go back, I guess. I'll go back and show you how to do it using the factor label. So I'm going to go back over here. I'm going to clear everything, I hope. There we go. Not what I wanted. Undo. Erase all ink. There we go. And I'm going to redo the whole problem using factor label, just for the people who prefer that method. You still start with the one you know the most about, or the one that's not asked about in the question. But now you've got 2 numbers, you have to decide which is the given. You don't want to start with molarity because we're going to need molarity in the conversion factors. So start with anything except molarity. So in other words, start with the volume. So start out with the volume being your given. Again, get it to liters, and if you want to do that in your head and start with 0.025, that's fine. As soon as you have liters, you've got to get to moles. We always have to get to moles because in order to do the changeover from KOH to H2SO4, you can only do that in moles. So I'm going to go from liters, because this milliliter canceled. That'll make that liter cancel, and now I can go to moles. Now, it's probably going to seem natural at first to use 22.4 because we've used that for so long. But remember, these are solutions. You can't do that. You have to use the molarity. And the molarity always goes with the moles, not the liters. So bring this down and put it in here. And then a 1 with liters. And then the mole-to-mole conversion. And this is KOH here because that's what we started with. And then what the question asks about always goes on top. So moles of H2SO4 on top. And I'm just going to go ahead and fill those in because you saw how to do the equation already. So I got those from the balanced chemical equation. It was 2KOH plus H2SO4 made K2SO4 plus 2 water. And you can write water H2O or HOH, it doesn't matter. And then what I do is I go ahead and get an answer here of how many moles of H2SO4, and then I do use the molarity formula to find the concentration. So 25 divided by 1,000 times 1.25 divided by 2. My calculator did not like what I did. Okay. Divided by 2 equals something that doesn't look right. Let me try that again. 25 divided by 1,000 times 1.25 divided by 2 equals 0.015625, which is what I had gotten before. Okay, then I just go back to my molarity formula because we're almost at the end here. 0.015625 divided by, and then you go up and you get the 50 milliliters, change it to liters. .05. And you get 0.1 or 0.3125, just like you did before. I'll just write it out here since I don't have a lot of space. Round it to significant digits, so 0.31 molarity of H2SO4. And that's your answer. So whichever way works better for you is fine. Just show me one of those two ways.